you saying you put two paragraphs inside the paragraph tag?
Yeah,
That might have been the
I start
I
the
one
exam
inside
zero.
one.
no, I did one inside one, but then you get paragraph.
You know, I've seen certain people for syntax. I've seen different developers create a div to class paragraph, and then
Yeah.
put all the different other paragraphs in that. So I think people like
Yeah, I
get
want to use
around
divs,
it. Yeah.
but this is just the professor saying we have to do it, and I'm like, I can't.
Okay. I think it may be possible, but I would never choose to do it that way.
I
Yeah.
didn't have any issue. But
No, you can. It just doesn't render. Like if you inspect the element, it's not a paragraph within a paragraph. It shimmies one up, one down, and then adds a string. So it has the same effect as a paragraph and then paragraph break within paragraph. But it's not. The browser isn't using a nested paragraph.
Have y'all done any cover effects and stuff like that?
but yeah.
I did a little bit of it.
Yes.
Okay.
How big is the
There's some cool stuff with CSS.
Well,
People actually think.
Um,
Some people
typically
focus on JavaScript for animation.
a perfect score on the bonus question is half a letter grid on the exam.
5 points.
Well, it's out of 100 points, so that'd be 5, yeah. Now, if you end up actually just getting 100% on the exam and you don't need the bonus,
You get 105?
some people know what I'm talking about. Then
Nerds.
unfortunately I cannot give over 100.
Will you tell us?
What?
Will you tell us if it's
If somebody how about this? So if somebody gets over 100%, if technically over 100%, I will write on the class whiteboard at the lecture after class the leader. I'll make it like a leaderboard. Is that a FERPA? Wait, actually, is that a FERPA violation?
Can we like
Wait, teacher.
If you don't put our names, it's okay. As long as you don't have our names. So you could do student 1, student 2, and we can each be assigned our own specific number, but we only know our own number. And if we have the ability to tell our own number, but you can't tell.
Okay, so what I could do is I could do one of those random number generators, assign each of you your secret identity number for the class, and then use that instead of your name. And then if you choose to disclose your identity, you may do so at your own discretion.
Yes.
How about that?
Yeah.
I like this. You may receive an email with your Matt312Z number. Okay. Actually, let's do that. So we'll make it like a leaderboard. So what I'll do is I'll put the student ID ranking. So let's do, how many people are there in the class? It's like 38 or something like that. So we'll make it to the top of 5? So top 5 go up on the board. And you get a shout out via your social security number. And if you want to disclose that you made it to the leaderboard, you may. And if you don't and want to be the sleeper student in the class that people don't bother for help with homework because now they know that you're good in the class, then you can be mysterious like Chloe. Dark, mysterious. Okay, so does this make sense? So what I'm going to do is wow. That is a really accurate depiction of how much energy I have.
Spectacular.
Okay, let me get a different marker. Okay.
Show us how to solve tests.
What I'll do is I'm gonna do a Dr. Lang style exam review. So you'll know exactly what you need to be studying, but and the question type is kind of actually not that important because it's linear algebra. I mean, if you know the definitions, you know which section to really focus on, which boxes to focus on. It's just, if you've chosen to not do your Pearson this entire time, that's entirely not my problem. And the other thing that's not my problem is if you've chosen not to read the book this entire time. So I'm assuming that you'll be fine. Question 1 is going to be the kind of like the definitions question like we were talking about. So definitions. And there's really only a few that are really super important to the class. Definition. So there will be multiple parts. So for A, you're going to need to know how to define, linearly independent, and also dependent, right?
Scott,
Yeah.
is this the questions you said that was gonna be like the proofing thing?
No. This is just definitions. Like, so just know these. I'm telling you that you need to know these definitions because. Yeah.
This may or may not be on the test.
Can't say for sure.
I'm an empath. I think it's gonna be on the test. Okay, the span of a set of vectors. Okay.
It is not a matrix, right?
And what defines a linear, specifically, transformation, as opposed to just a general mapping? What properties transformation? And then, once you have these definitions, there will be a very, very straightforward, not tricky, not gimmicky question that relates to one of these three. It'll be a very straightforward, point blank, not a proof, just a basic computation that involves understanding the definition, just not rote memorization of the definition, okay? So I'll call that an exercise because that's kind of what an exercise is by definition. Like, the function of an exercise is to introduce you to definitions and then apply. But it'll only be about one of those three. So you could either gamble and spin that wheel for 1 in 3 chance, or just know all of them.
For format, is it gonna be like short answer, right in? Or is it gonna be, because the Pearson is multiple choice, true, false,
Okay.
essentially.
I see what you're saying. So the way that your page is going to work is one of my pet peeves as a math student was when I would try to take a math exam, and then the question, there would be like the question, and then the professor would only give you like a little bit of white space to put in your work before the next question. And I was like, that's a choice, right? So what if I just give you the entire page per question? So the way, if you took Calc 3, you know what I'm talking about, right? It'll be the question as the top header, and then there's going to be just a blank sheet that goes all the way down with the rest of the space to answer all of the parts. So yeah, you will not be doing any true, false, none of that. It's basically just from your brain onto a paper with your pencil. And this will be, you'll compute something. Okay, worth 20 points. I like even breakdowns on this, so 5, 5, 5, 5. And I don't feel bad saying that because when you actually open up the test, for each question in each part, it'll literally, like the way I coded the LaTeX document is it'll have the point values assigned to each thing anyway, so it's not like that's a mystery to anybody. Okay, question 2 is the first major proof of the course. Oh, now that one is actually got ink in it. Okay. Question 2, and this is going to be all about span. A proof involving, why do I spell span with an F?
I don't really know.
Span.
It's creative, you know.
Creative license.
Exactly.
That's what I do my BA in. Span. And this question, a few things about it. It's a proof. Okay, so it's only one question, and there's not going to be multiple parts, so you'll have the time budgeted to that proof. And yes.
Making sure, is the first question going to be A part B, or is it just going to be just like how are you literally just
Question
doing?
1, part A through B.
Oh, it's question 1. I thought you okay.
What about this is confusing?
Hmm?
I'm trying to understand what's confusing.
Oh, it's just I thought you said that you were going to do like exercise based on one of the definitions on the board, A through C. Are you saying it's going to be computation to prove that you understand A through B, or a possibility of A through B, A through C?
Oh, this exercise will be something that involves one of these three concepts.
Yeah, so it's one that's by one of those three, not all three of those things. That's A, part A, part B, part C.
Yes, that is kind of what it means when I say that it's about one of the three. Like if I say it's about one of the three topics, that means it's going to be about one of the three topics. So like, if it's about the span, then it's going to be about span. If it's about linear transformation, it's going to be about linear transformation. It's about linearly independence, it's about linear independence. Does that make sense?
Yeah, I'm kind of confused still, but it's okay.
I know why it's confused.
Are you asking?
I think it's confused because you're gonna like choose one.
Yeah, are you
of
doing?
those.
It's
Oh,
not,
no, you have to answer all parts of the
Yeah.
question. I'm just saying that the type of computation you're doing is, you're not going to have to do it, it's not going to involve all three of them.
You're gonna do
You
something
have
that's
to-
all, and then
you have to write the definition of A, the definition of B.
Oh, clean makes it.
Yes, you're still doing 4 parts of it.
Okay, making sure.
Definition.
Oh,
Yeah.
okay.
Yeah.
I was like, roll the dice with one of them. All right, it was like all three of them. Then, yeah, I get it now. W Riz, I understand. You're cooking. The cooker. Notice your Discord name is the cook now.
Don't worry about
Okay,
that.
so question 2.
Question 2.
Please
Please move on.
You can't do this anymore.
Got them moved on, which is fine.
Is that it? Okay.
So what do you mean by proof?
Proof of what?
There's going to be a statement that you will need to prove.
Yeah. Understand.
And it's about... I know, okay. I will... Once I'm trying to get the outline. Once I get through the outline, I'll actually talk more about the proof. Because, again, like I said, I will teach you what you need to know about the proof styling and proof language. I'm just trying to get through the topics, okay? Sorry, I'm still a little thrown off by that. It's throwing me back to some conversations I've had in the past. And those.
The
Yeah,
cook.
Flashback.
This is going to be all about section 2.1. So this is matrix operations. From 2.1, right? Pretty much every operation that we learned how to use is going to be involved somehow in the computation. You're going to need to know how to multiply, you'll need to know how to add and subtract, you need to know how to do transpose, you need to know how to take the transpose of products, you're going to need to know how to do exponents and do that kind of stuff, okay? Yeah, actually, okay, so the way it's going to read is it's going to be let, and then it'll be A is, B is, C is, compute something. And that's just going to only be matrix operations. There's nothing crazy, okay? That problem is going to probably be the most difficult one on the test. I anticipate most people losing their A's and B's to that one. Okay? The other one that people are going to lose points on is question 2 because they're not going to pay attention to how I teach it today.
it's just gonna be one computation, but we have to learn all the different things. Like,
You can learn half of the linear algebra and
I mean,
get half the point.
I'm assuming it's just gonna have everything involved.
That is a really excellent assumption
Yeah.
because that actually happens to be a correct
A
one.
times
Yeah.
C.
See what
We're
it
gonna
says?
be transposing A squared
Yeah.
times.
Inverse AB.
I promise. Now, when you look at the problem, it's gonna look very unfair, but it is actually a very, very straightforward problem. Okay.
2x2 matrix.
So just do what looks like the first step.
Yes.
Yeah.
Okay. Then things will get a lot easier. Things get a lot easier. The last two questions are the easiest in my opinion.
Pretty sure. So it's a reverse.
So question 4 is all about our favorite
That'd be good.
invertible matrix theorem. That's the M is going crazy. Okay, so you're going to need to just state the invertible matrix theorem. And then there's going to be a very, very easy, short question about it that involves simply citing something. So like if you have this memorized, answering this question, you could refer back to the theorem you just wrote down and figure out the property to solve it. Yeah.
Can we write the flowchart as the theorem?
Unfortunately not. If you want to ask for a piece of scratch paper and it's easier to memorize the flowchart and then use that to write the entire theorem, then do that.
Okay.
But I will not accept a flowchart as a statement of a theorem.
Just curious.
What did it say again? State what?
Invertible matrix theorem. Yeah. IMT. So this is going to be just basically not even a computation. Basically, open your eyeballs. Open your
It's a sweet question.
eyeballs.
It's the opposite way.
Open.
The answer to this question you'll be directed will be either yes or no.
A true false.
So basically a true-false question. Okay, I guess there is one true-false on there. But that's just because the statement of the IMT is worth a lot. That's 14 points. The point breakdown for the invertible matrix theorem, you get a point for the quality of you need to state that you need to declare A to be n by n. You get a point for then stating that the following statements are logically equivalent, and then 1 point per, and that's up to 14. So 14, and then that makes, I'm throwing away like half a letter grade to a true or false question. Yay! Okay. If you get it wrong, I'll honestly just be disappointed. Actually, not disappointed. You ever just watch like your cat try to jump onto the table to steal your food, and then it just wipes out, falls down, and is like, ah! And you're like, you don't want to laugh at your cat, because you're like, man, my cat. But at the same time, you're like, if you weren't so bad at jumping on tables, you would be fine.
That's why you never get a cat.
Okay, question 5. The last question. Now, we haven't actually learned this, but we'll talk about it on Monday. Okay? So I'm just going to put down the topic. It's going to be, it'll be find an L. Well, that's not an L.
It was close.
That was actually really close. Find an LU factorial. We'll learn what this is on Monday, so don't freak out. Factorization of a matrix.
After we learn it, how hard do you think that question is going to be? So right now it's intimidating because we have no clue what it is. But how hard is it actually?
5 minutes tops if you're practiced. Easy.
Okay.
Okay, here is my, you know how Rotten Tomatoes that gives you the tomato meter rating for stuff? So I'm going to give you the Scott meter of difficulty. What?
Instead of tomatoes, bananas.
It's a bonus question.
Yeah, what's gonna be?
It's not actually the score that critics give it, it's whether how many critics give it a good score versus a bad score.
Okay, so the Yelp review. Assuming that you actually just memorize it, there's no way to not get the points for that. So I consider question 1 to be a 1 out of 10 difficulty. Okay? The only reason it's not 0 is because technically you have to memorize something. But if you memorize it, it's free money, okay? This one, because you guys are not math students, you're STEM and engineering and all of that, this could be a little bit more difficult. So I'll give this a solid 4 out of 10, okay? This one, because there is a tendency for sloppiness that is incurable in your demographic. This one's, the way the partial credit goes down, that's the way that it's going to be kind of brutal, I'm not going to lie. I'll put this at a 7 out of 10. And then this is like a 1 out of 10, and this is like a 1 out of 10. Okay, this is, so those ratings assume that you actually just memorize what you're supposed to and have done your homework. But yeah, in question 3, lock in, use scratch paper, use scratch paper.
5 pages.
Because, yeah.
Scott, time estimate on question 3.
Time estimate on question 3. Well, let's think. So you got 5 questions overall, right, for a whole hour. And I think I might be able to get you can come early. So instead of coming at 1:15, if you show up at 1 o'clock, I can give you, and you can start. So that gives you an extra, 15 minutes? So, extra 15 minutes for the bonus if you want to take the bonus. But even if you used only 60 minutes for it, that's still 12 minutes per question. Do you think it takes you 12 minutes to just handwrite 3 definitions? You think it take you 12 minutes to just handwrite a theorem? This is not going to take you 12 minutes. This one, so yeah, budget for these to be the ones that you're spending more time on. So, honestly, if I were a student, I would start with question 1, skip to question 4, and do 4 and 5, and then go back and do those. Because you don't want to rush through 2, and you do not want to rush through 3. I will be actually very impressed. If more than 5 people get question 3 right, I will be very impressed actually.
So the goal is to make it right.
We need for you to remix the
Basically, if you get it right, you're on the list.
And we get.
There's gonna be a
The
proud list.
leaderboard will just be 1, 2, 3, first place.
Or everyone's in last.
Just the curve.
Okay. Do we want to see? Do you guys want me to show you a proof that is going to be very similar to the one that's on the exam, or you got it? I think honestly,
I was saying I don't.
you guys are a bunch of smart cookies. I think you're good. All right, let's start. Let's do this democratically. Okay, raise your hand
You are.
if you want to see a proof example. Did someone just say keep your hands down?
Wait.
Now, actually, sometimes jokes have ramifications, right?
But I was actually sitting on the ceiling, so our hands down were still up.
Oh, it's alright, I see.
It's just inverse.
It's an inverse matrix.
Okay. In that case, let's do a proof, yeah?
Yeah. Woo.
And just be, we could probably take a regular picture approach, just be like compared to
I'm still
It's
still very
If everybody gets question 3 right, can you do like video?
Okay. Now, here's where I need everybody to lock in. Okay. If I show you the proof, I need to make a decision. Am I going to show you the proof of the actual question or just a related proof?
Actual question.
But the thing is, if I show you the actual one, there's going to be a lot of students who then will fail it. They will find a way to fail it.
Okay.
And then that will hurt me emotionally to the point that I might just make the final one question. I don't feel like doing a one question final in this class. So let's do a similar. I'll do a similar one. So that way.
What if in theory you show us two and we don't know which one's right?
You know, I'm gonna be so for real. If you guys without Jessica right now would be not looking so good. I know. I was about to say. I like this. I like this.
The union rep.
Okay. Actually, what I'll do this is I'm gonna do this. I'm going to modify the question, but if you understand it in principle and in concept, then actually executing the real one is not going to be, by stretch of an imagination, difficult. Okay? And let me think about this. Yes, I have a way to do that. I can show you not the question, but if you can understand truly this one, then it will translate very well. Okay? How about that? And then that way you don't have to think about the one question final at the end of the semester.
Did you have a good time?
What's funny is for Calc 3, I told them that if they messed up this one question, that I was going to give them one question final, and then nobody messed up that question. So I deleted the file on my computer. That was literally the one question final.
I would have taken the one question final for him.
Why are Okay. Actually, if I did a one question final, I know what it would be. It would be to prove basically prove every single connection of the invertible matrix theorem. So you would start with A is invertible and be able to prove every single part.
Do the whole stick man?
The entire thing.
Can we?
But the thing is, we're only in unit 1. The invertible matrix theorem gets longer as the class goes on. So you would use the entire 2 hours proving 20 different things. But, so a discussion on span. So first things first, span. Actually, I'm gonna put the definition related stuff over here so that we can use it for reference later. So this is just a little bit of review for the sake of you guys actually learning something from this class. Span of a set of vectors, v1 through vp. By the way, in terms of notational correctness, if your work is not using the correct conventional notation throughout the exam work, I have left a little part on the exam that does technically give me permission to zero everything that is not written correctly. Have I ever actually used that? No, but it's there if I'm frustrated enough, okay? So, this is, what is the definition of span of a set of vectors v1 through vp?
Yeah. Okay. frozen.
Okay, so that's the math notation. What is the signify in concept?
That you can, the span is like the constants that you can multiply if it's in the grill, if it's the real region.
Do we know what we call this type of an expression? A what? What do we call that? Linear combination.
I was trying to do the same thing.
Okay, so now that we've identified that this is called a linear combination, interpret this in English. What is the span?
And the set of all for OSC is real number.
Yeah. I think Prem, what were you saying, Prem?
Oh, the set of all possible values that can be reached by like using a constant multiplied with the vectors.
Mm-hmm. So basically, all possible linear combinations.
Yeah.
Span is the set of all possible linear combinations. So if you don't know what a linear combination is, you won't be able to do this proof. If you don't know the definition of span, you will not be able to do this proof. Okay? So, what does the statement x in span v1 to vp signify? What does that actually imply?
That some vector x can be created using some linear combinations of the vectors.
Exactly. Is that there exists weights C1 through Cp such that I can express my vector x as a linear combination of those vectors. Does that make sense?
Yeah.
Are we sure that makes sense? If a span, okay, somebody tell me, what is the span of a set of vectors? Ergo, being a member of the span logically implies,
It's a linear combination of the vectors.
okay, you see how those dominoes fall together. Those two are key pin parts of the proof, okay? And by key pin, you cannot finish the proof without either of those statements. Does that make sense? Okay. Now, say I have a vector y that is in the span of this same vector set. What does that tell me?
There exist weights such that y can be written as a linear combination of the vectors.
Did everybody hear Rebecca there?
Mm-hmm.
What did Rebecca say?
That and y, I mean, there's such this was that y can be written as a linear combination of c, I mean y, I mean v1, c1 to
It's mighty quiet. I may just call it a day.
no,
I think I'm gonna go to bed.
nah, we can talk more.
Whose exam is it? Yours! What's the span?
Set of all possible linear combinations.
So to state that a vector x is in span of the vectors, what does that imply?
There's no solution of linear combination. It's some linear
Okay.
combination.
And if there's some vector y in the span, that implies what?
That's a linear combination.
Okay. There's something that Dr. Foster says in the theology department that I really like. I don't give you your grade. You earn your grade. So if you get an A, that means I didn't give you an A. That means you earned an A. You don't, that does not not mean I gave it to you. It means you earned it. So, do you see where my concern is with these definitions? Because we're a week away from the first unit exam, and this was covered in like weeks 1 and 2, and apparently, like 3 people in the class know these definitions, okay? So can we have that locked in by Monday?
Totally.
So,
Super Bowl.
what we're going to do is we're going to prove, let's see. We're going to prove the following theorem. And again, this is not the actual exam question, but if you can do it, you'll be fine. Given a set of vectors, v1 through vp, and also a sum x and sum y, we'll give them n entries, so they're all in the same size. And if I know that both x and y, which are not equal to each other by the way, well actually they could be equal to each other if we wanted, so I won't make a specific. If they are in the span of these set of vectors, show or prove that the vector x plus y is in the span of v1 to vp.
So how would you write the statement that states that like C1 can be coordinated to M? You know what I mean? Am I saying that right?
Are you talking about something over here?
Yeah, like how if I don't know actually.
Okay. So, what do you guys have your notes from class on Friday? Wait, today is not Friday. Yeah, from Friday. Okay.
It's Monday.
So we want to do a few things. We want to make sure we're articulating. We need to call, basically declare our variables. We need to assign what we're talking about. And then we need to articulate what we're trying to show. And then we need to just make the correct observations from the definitions. And then let the logical consequences follow. Yeah? So in order to even begin this proof, in order to show this to be true, I need to call in a set of vectors. I need to call in a set of vectors v1 through vp. That's the first thing I need to do. I need to call in some 2 other vectors, x and y, in Rn, specifically these 2 vectors being in the span of that previous set. So I can do that this way. I can just simply say let, here's that let word, v1 through vp and x and y be in Rn, where I have that x and y are in the span of v1 through vp. So far so good? All I'm doing at the start of the proof is I am articulating. Why are you on GC1?
Sorry. I was just.
Come in.
I was just going out for a walk and I heard a familiar voice.
Come here.
Okay.
This, everybody, is Matthew Probst.
Hello, everybody.
He is one of the wisest people I know in terms of translating and reading Greek. So if you have questions about the New Testament, ask him, bother him, don't bother me. We're co-teaching Greek 1 and 2 this semester together. So, tell them one thing about the New Testament that they probably have not heard.
I have not heard. Oh man.
You have 10 seconds.
Well, you ever hear? This is one of the things that Derlingat talks about all the time. The difference between logos and rhema. Some people will say that logos means something along the lines of like spoken word, and rhema being written word. That's not really the case, as it turns out both can mean either written or spoken word. Just one's encompasses a whole spectrum of ideas, while rhema is just a tiny little speck in that logos that can be either written or spoken word. So
there you go. Now you know something about your God. Thank you.
I will remind you sitting in here.
Yeah.
Please.
In the very back.
I have a question. You mean real number, or do you mean like in the terms of like m by n?
In the reals of some dimension number n.
Oh, that's what I was at.
Okay. Do we know what Rn means?
Yes.
If you know what Rn means, raise your hand. Okay. What does it mean?
And number.
Okay. Okay, so we have our ingredients. Now what's typically the thing that we do? I need to show this. Okay, so I want to be able to show that this is in the span of V1 through VP. So let me articulate what I want to show, alright? So the task here, so what's my task? We want to show, so here's a key connector idea. We want to show that the vector x plus y is in the span V1 VP. Yes? Is that not the whole purpose of doing this proof? Yes? How did I know that that was the goal? Maybe because that's what the problem says. Yeah? Cool. So far, everything in this proof comes straight from the problem. Have we left any details missing from the original prompt? No, we've accommodated everything. And that's a good sign that we're going to do this right. Now, let's articulate this in actually human, understandable, not weird terms, okay? So what does it really mean for x plus y to be in span? Well, that is, and here's a really excellent phrase, that is, great logical connector. It's basically going to reframe what you want to show in terms of its definition. Okay? So, what's the definition of span? So if there's a vector in that span, what does that mean? Okay, here's my question to you. Is x plus y a vector?
Yes.
Yeah, it's a vector. I've just declared that a vector is in the span. So what is that? What does it mean if I declare that a vector is in the span? Oh yeah. Okay, so that is x plus y. Well, actually, I could say I need to declare the. You can either declare your scalar weights before or after. It's typically good form to declare them first. So that is, there exists, and now we need scalar weights. So there's going to exist some, we can call these whatever we want. So if you use some like random letter, I don't really care. So long as it's, it's consistent. So we need some A1 through A. How many weights do we need? Why do we need P weights? Yeah. What type of objects are these A1 through AP? So I need to designate that they are in R. Okay. If you omit omit that, those two symbols. Okay. Okay, so there exists A1 through AP in R, that is, there are weights such such that what?
X plus Y.
Yeah, I can express this vector as a linear combination of those vectors. Yes? This so far makes sense. So, what have we done? I've declared my variables. I've declared what we need to actually be operating with. Then, I'm articulating my logical connector. We want to show, what do we actually want to show? I go to the statement of the theorem and say, this is what we want to show. And now, that is, I'm reframing what we want to show with something that actually makes sense, interpreting the definition of the concept involved. There exists weights such that it satisfies the definition of being a member of the span. Okay? So, now let's actually look at what we got. So we've stated up here that X and Y are in the span. So now we are going to do some observing. We see that, here's our connector, we see that X actually, do I have space to fit? I want to be able to fit it all on one whiteboard, so I'm kind of budgeting without a mind's eye. I'll do it like this. We see that X and Y are in the span as well, which logically implies what?
That they can be described as some constant B1 until constant BP.
Yeah, we can find, okay, everybody, what's the definition of span? Okay, so to declare that X is in the span means
There exists a linear combination. What is that like?
and to say that there's a linear combination, what ingredients do I need to make a linear combination? Scalars. Okay, so if I'm saying that these two vectors are in the span, what does that imply? That there have to be scalars. Now, I have two separate vectors, so how many sets of scalar weights do I need? I need two, and they need to be distinct from each other, right? Okay, so again, the variables you use here, I don't really care so long as they are distinct. So don't choose A, okay? What would be wrong is reusing the A variables because those are already used to designate this. Okay, so don't do that. So we can just choose another letter. Let's go with C maybe. So C1 through CP and D1 through DP. Okay. What kinds of objects are those? Okay, so what do I need to make sure I include? In R. Okay, in R. So finish the logical thought. So X, Y in the span implies what? So we have the existence of these weights. Why do they exist? Such that why would I declare weight C1 through CP?
So then you could do the weights for X and the weights for Y.
There we go. So
But
X can be written how?
C1D1 plus
C1 X
and Y equals
D1 and another D1. for the the real signification when you're supposed to put, signify what dimension is in, because in this time that you didn't put that is in the dimension of n.
It's in R1 because all scalars are only one dimension.
Yeah. So then why?
And undefined generally means one.
But then up there is, never mind. You didn't use one up there. You only used it up there. You used it because in the scale. That makes sense.
We good?
Yeah.
Okay. So let's recap what we've done. We declared our variables. We want to show, we articulate what the proof is even supposed to be about. We reframe, that is, by definition, what that actually means. And then we make an observation about the givens. We see that, well, okay, if my x and y are in the span, that logically implies, and then boom, definition again.
So you're saying that when you said we see that wrong step 2 from the task in light of the given definition, or are you saying that we're on different, still in the first step?
What are you trying to?
Oh wait, no. But you've given us a thing that says the elements of a proof, and you said the first part was to articulate the task, and the second part was from the task in light of the given definition n. And then the third part was use all given ingredients. Then 4 is let, we see that, we show that. So what would you say what step you're on right now? 4.
We're on now on the last one.
4.
Yeah.
Okay. So we have everything that we need. We're going to now, we've set ourselves up to do the creative part of the proof where we actually now do something. We show that. Good proof always circles back to your we show that. Because what did we want to do? We wanted to show something. So if we never get around to showing it, then we failed. So we show that. Okay, what were we originally trying to show?
X plus y.
X plus y. Okay. So x plus y. What is x plus y? Well, in light of now what we've defined, right? So we've now said if x and y are in the span, then that means they have to be able to be expressed as certain linear combinations. So let's use that perspective. If I have x, that's C1V1, CPVP. And then y, because I know it's in the span, then by definition, there has to be this linear combination D1VP, or D1V1 plus DPVP. Yeah? Bless you. Now, if we combine like terms, what's C1V1 plus D1V1?
C1 V1 times C1 plus D1.
Yeah, so we have C1 plus D1. We combine those together because those are like terms. And we combine all of the like terms. What's this one going to be?
CP plus DP VP.
Okay.
Can we just since vector x plus vector y equals to av1 to ap plus ap times vp, right? Vector vp. Can we just because since a1 is all the real numbers, can we just set c1 plus d1 equals to a1 and we just prove?
Okay, yeah, so I see what you're saying. And what you're doing is you're saying, well, was it really necessary to state this line? Why didn't we just cut down to the chase? The answer is because, although that is preferable, I'm assuming that none of you have written proofs before. So, yes, you are right. If you didn't want to say that is blah, 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 and reframe your question in terms of the definition, you don't actually have to do that step. The only step that's optional in here is this one. Okay. So you don't technically have to include that. But I'm including it to motivate the conclusion. It'll make the conclusion easier to understand. Okay? Because from here, I'm going to put a period. Oh yeah, by the way, when you do a proof, mathematical objects you treat like grammatical objects. Okay? So like, have good grammar. If you have a sentence with math in it, put a period at the end of it. You know? If you have a something and then an expression and then you continue on, put a comma after it. You know, punctuate your math into your sentences. Okay, so we've shown that the sum vector x plus y is this linear combination. Okay, so what?
Would it be wrong that we, for that step, that we started with just the x? I mean, the vector x plus y exists span v1, then that, or would that be wrong?
Again, this stuff from there to here is technically optional. I'm including it for educational purposes.
No, I meant the thing. So the thing on the top in the theorem given statement that you restated right before the optional thing, would it be wrong to state that, then go on to state everything else after, like the
question?
Yeah, literally the parentheses.
This?
Yeah, if you stated that, then put the vector x plus y equals, like literally what you said, just put that right before it, would that technically be wrong?
Yes, because you didn't declare that you can conclude that these linear combinations even exist. Okay, I'm only able to use these linear combinations because I'm citing that they are in this span.
Okay.
So if you just completely circumvent that, you're using objects that you haven't defined in the proof.
What a span? What a span is? I don't know.
Okay, so
We don't, that there we didn't define A.
Yeah, I'm
Yeah.
not saying that we're taking it out. I'm saying if we copy that and put it back on the end of it, I'm putting it in front of it to state that that's the same thing.
Like if you literally just rewrote again after we show that the parenthesis x
Yeah.
plus y span VP and then the equal to the
Yes.
linear
So
combination.
you want
He's
the
basically
we
just
want to
asking,
show to
can
just
you
that we show.
rewrite it again?
No, I want
Would
to
that be
literally
incorrect?
put that
You want to write it
X.
twice.
Yes,
Okay.
I want to write it
Let me
twice
put it-
to
let me-
state it in the beginning.
let me make a disclaimer. Okay, technically, proofwriting isn't like doing a row reduction or like a computation of the matrix. There isn't an exact science to it. It's either going to be logically correct or logically incorrect. If you don't want to use this exact wording and style, then don't. But if you have a gap in the logics, and if I'm reading your proof, and you go from one point to the next, and it's like, well, you're not allowed to do that. You never declared what happened in there. Now it's wrong. Now, if you use different wordings and maybe you streamline it and you're more efficient, but it still contains every logically necessary component, then yeah, it's good. So let's say it that way. You don't have to use this exact template. Okay, this isn't like a triple integral where it's pretty straightforward what steps you have to do. It's a proof, which means that the components that we're dealing with are logical in nature. You are either logically correct or you're logically wrong. You either have statements that do imply each other, or you have statements that don't imply each other. You will either have assumptions that have been justified, or assumptions that are just straight assumption without justification. Okay? How you choose to word that, how you choose to notate it, the order which you choose to do it, doesn't matter to an extent. But some logical things have to precede others. Like, so the order matters in the sense that I can't be citing this if I don't even declare what the linear combinations are. But if you declare that before and want to go immediately from that to here, then that's fine, so long as everything is declared. Okay? So proofwriting is about logical consistency, not about word for word copying, okay?
You can write it again, it's just redundant.
Okay.
Yeah.
Yes, the way it's written here isn't like this is the way. This is a way that I am using to teach. It's an instructive proofwriting, okay? The way that a grad student would write a proof for this is very different than the way you as undergrads would prove this. because they have more background and more shared assumptions and more skill that's implied that you guys don't have yet. Undergrad proofwriting is very meticulous because we need to make sure you actually know what you're talking about, so that we are not, so that the person who's reading your proof isn't just getting gaslit, that you know what's going on, okay? So if you just declare your variables and be like, it's obvious that, boom, I'm gonna be like, well, unfortunately, you're an undergrad student. It's not obvious, and that is a bad proof. Okay, if you're pursuing your PhD and this is just a corollary in the middle of your paper, I would sure hope you don't have to know how to prove this because you should have proved it in your undergrad. Okay, so there's context to these things. Does that make sense? Okay. So, how shall we proceed?
Therefore,
what were we trying to show this entire time?
yeah, therefore we have showed that
Well, we have to say that C1 plus D1 are also in R,
Yeah.
therefore they're scalars, and then
So-
we can set A equal to that, then.
There are many valid ways you could write this conclusion statement. I'm going to choose one that is consistent with the method of teaching for this proof. But if you don't write it exactly like this and you write your proof your own way, then that's fine. Oopsie. Since we can assign AI to CI plus DI, the vector x plus y is in the span V1 to VP. That is, I've already declared that these weights are real numbers. I'm taking advantage of the fact that I've already declared these as being scalars, so that I can use that object down here without having to declare something else. And then this AI simply indicating that it is, like A1 would be C1 plus D1, A2 would be C2 plus D2. This is just general case, so I don't have to write that all out. Then that's just satisfying. This is a demonstration that this is definitional. Okay.
what's the box in the corner?
Signify the end of the proof. Okay, does this make sense? Are we sure? Do we understand that you don't have to do that word for word?
Yep.
So long as it's logically consistent. Now, the reason I'm very picky about this kind of stuff is because when I was a freshman, taking my higher algebra course, I didn't have anybody to teach me how to do proofwriting, okay? So the way I learned how to proofwrite was I read a few hundred proofs, I wrote a few hundred of my own proofs, I made a lot of mistakes, I tested it against people who wrote papers regularly, were up to date on the style guide, read a lot of articles, read a lot of journals, got inducted into the style, and then just made the practice of doing it on my own. And if you never do that, then yes, it's not going to make sense. You don't want to depend on somebody else's thinking for you, okay? Because this is about the most explicit I will ever get for demonstrating a proof in this class. The rest of the proofs in that I'm going to assume you are equipped with the tools, and I think it is healthy to experience what it's like to have no idea how to do something. Like, when you really think about it, when you leave with your degree and you're going to enter a job, well, your job isn't following your school's curriculum and going to give you a problem and a task that you're just like, I did that in Unit 7 of my class, right? it's going to give you a problem that nobody's really solved before in the company, because that's kind of why they're paying you, right? So if I don't start the process of teaching you that it's okay to be given a problem without any sense of direction, I'm like, well, that's not fair. How am I expected to solve a problem if you don't tell me how to solve it? Why are you in this degree? Because the whole point of spending $44,000 a year to take these classes is to begin in a safe space and safe environment the process of being required to solve problems that have not been demonstrated for you, okay? So if there is any sense of future entitlement for knowing how a proof works, I will be more than happy to oblige you. I will join you in your suffering, but I will not alleviate it. Because the only way you're going to learn how to do these things is by handling being stuck. If you can handle being stuck, you're going to succeed. If you can't get yourself unstuck, keep practicing until you do, okay?
Is it okay for, in the middle of writing a statement, for you to use the next line in the middle of an equation, or is that technically wrong?
Well, I mean, if it gets too long and you need to format it to accommodate, yeah, that's fine.
Okay.
So long as it's clearly communicated what you're doing. Questions about the proof?
No.
Questions about the definition of span? Oh, you actually got 2 questions today. I just realized that. Yeah.
So how could you, if that line is optional, how could you state the AI equals CI plus DI if you were going to take that out?
I wouldn't be citing objects that do not exist in the proof.
So that means it is mandatory for this to have that statement in this circumstance because you have the
Yes, that sentence is conditional upon the fact that I've declared what those A1 through AP are.
Okay.
If you choose not to do that, then you'll need to find a different way to express the same thing without those.
Okay.
Okay. Well, this is that you are officially dismissed if you want to go.
When we declare C and D, that they